Our next example, we're doing some subtraction and addition with matrices and bringing in scalar multiplication. So here we're asked to find 3a minus 2b. Plugging in, we know we're going to have 3 on the outside. A is -4, 1, 3, 0. And we need to minus 2 times b, which is -1, 8, -2, 5. Okay. All right. We know that scalar multiplication means that we take each element in our matrix and multiply it by the scalar, which is the constant real number out front of the matrix. But remember, that just means distribute the 3 through. So 3 times -4 gets us -12. 3 times 1 gets us 3. Bottom row, 3 times 3 gets us 9. And 3 times 0 is 0. Okay. With the -2, you have 2 options. You can either take 2 and multiply the 2 all the way through, or you can multiply -2. If you distribute, or if you multiply by -2, the sign switches to addition. Okay. If you multiply by +2, you keep the negative in between. Since most of us were taught to carry the negative with the 2, I'm going to distribute the -2. So I'm going to change mine to a plus on the inside. -2 times -1 gets us +2. -2 times -2 gets us +4. -2 times 8 gets us -16. And -2 times 5 gets us to -10. Our first matrix is a 2 by 2. Our second matrix is also a 2 by 2, which means that we can add them. Remember, adding them, we're going to add corresponding elements, which means that we're going to have another 2 by 2. We're going to have -12 plus 2 in the top left. We're going to have 3 plus 4 in the top right. We have 9 plus -16 in the bottom left, and 0 plus -10 in the bottom right. Don't forget your brackets around your matrices. And if you still don't like how these look together, remember that you can also throw in those parentheses to make sure that your numbers stay together. And now we need to do the arithmetic, make things look pretty. -12 plus 2 gets us to -10. 3 plus 4 gets us to 7. 9 plus -16 gets us to -7. And 0 plus -10 gets us to -10. And again, we have 2 rows, 2 columns, which means that our dimension did not change, and it will not change with addition and subtraction. Our next example is a matrix equation that is not going to require us to use inverses. It says solve for x. This 4 shouldn't be in here. There we go. Get rid of that. Solve this equation for x, and they give us a and b. A, if we're counting the rows, we have 2 rows, and then we have 1, 2, 3 columns. So we have a 2 by 3. If we look at B, we have 1, 2 rows horizontal, and then 1, 2, 3 vertical columns. So it's also a 2 by 3, which means we know that we can add or subtract if we need to. Let's plug in just like we did on the last one. We have 2 times x, and we don't know what x is. We're going to get there. Plus a. I'm going to write out what a is. We have 5, negative 7, 13, negative 10, 2, 11. And that's equal to b. And b is negative 15, 12, negative 6, negative 21, negative 14, and 20. So we're solving this equation for x. So we are trying to get this x by itself. If I look at that equation they originally gave us, the 2x plus a equal to b, if we were solving this for x, the first thing you would tell me to do is subtract a from both sides. And that's what we're going to do. But here, A is a matrix. So we're going to subtract this entire thing over to the other side. Okay. So my 2x stays the same. My B, my green matrix, was already over on the right-hand side. So I'm just going to copy him down real quick. And we are going to be now subtracting because he originally was plus. So originally added, but we're going to be subtracting that purple matrix, which was 5, negative 7, 13, negative 10, 2, 11. Okay. And if you watch the video on the subtraction, I showed you how you take your corresponding elements and subtract them. So in the top left corner, we're going to have negative 15 minus 5. And I would go through and do all of these steps. Here, because I know you're getting sick of writing all of the steps down, if you want to start skipping steps, you can. Let's do it in our heads or with the use of calculator, whatever you want to do. Okay, so we're going to have negative 15 minus 5, because we're doing negative 15 minus 5 gets us negative 20. We're going to have 12 minus negative 7. When we subtract a negative 7, that means that we add 7. So 12 plus 7 gets us to 19. Negative 6 minus 13 gets us negative 19. Let's go to that bottom row. Negative 21 minus a negative 10 becomes negative 21 plus 10, which gets us negative 11. Negative 14 minus 2 gets us negative 16. And 20 minus 11 gets us 9. We're not done quite yet because the x is not by itself. Okay. We're still solving for x. If we had 2x equal to, I'm just going to take the first entry in our matrix, negative 20. To solve this, you would tell me to divide both sides by 2. Okay, so let's do that. We are going to divide both sides of our equation by 2. And if you are in a higher level math class, your professor would freak out at the fact that you're writing it like that because we don't divide with matrices. They would want you to write it out as 1/2 times our negative 20, 19, negative 19, negative 11, negative 16, 9 matrix. But you know what? It does the same thing. So we're going to take each of these elements and divide by 2 to get x by itself. Negative 20 divided by 2. I know that we don't really like fractions, so here, I'll write these ones out. Negative 20 divided by 2. We're going to take 19 and divide it by 2. We're going to take negative 19 and again, divide by 2. Bottom row, negative 11 over 2. And negative 16 over 2. And 9. Again, all over 2. And don't forget your brackets as you work. Now let's simplify. Negative 20 over 2 gets us negative 10. 19/2 doesn't reduce, and we're not going to use decimals. So 19 over 2. And negative 19 over 2, because it doesn't reduce for negative 19 either. Negative 11/2 doesn't reduce. Negative 16 over 2 gets us negative 8. That is a jacked up 8. Let's try that again. Negative 8. Still not great. And then 9 divided by 2 doesn't reduce, and we get 9/2. Notice that we have a 2 by 3 matrix. So the order that we had for A and B didn't change. It stayed the same because we were adding and subtracting. The multiplication by a scalar, a constant non-zero number, which in this case is 1/2, did not change our dimensions. It just changed our elements.